Alright guys, welcome to lesson 10.9. Today we're going to be learning a new way to plot points called polar coordinates. And then we're going to learn how to use trig ratios to change them from rectangular coordinates, which are what we're used to, into polar coordinates. Now you might not be used to the word rectangular coordinates, so you might be thinking, what do you mean I'm used to that? Well, I'll show you what those are in a minute. You just didn't know what you know what these are, but you're just not used to calling them that. But basically, this is something we know. We're going to change it into something we don't know using trig ratios today. Okay? And those new things that we're learning are called polar coordinates. So, what are polar coordinates? It's a different way of plotting points on a graph. Instead of using x and y, we use r and theta. So, let's see here. You guys may know, you don't need to write this down because it'll be on the next slide, but we're used to plotting points that look like this, right? We know this means x, this means y, so that means I would go over 2 and up 5, right? That's that. But there's a different way to plot points instead. Instead of plotting the point by going over to the right and up 5, another way you can think about it is a distance from the origin that has been rotated that far. Okay, so we look at a distance from the origin, how far away it is from the middle, and also how far it's rotated away from the x-axis. And you get the same point that way. So if I told you this was like, I don't know what it would be, but I'll just make up a number here, like let's say it was 6, this length of this line, and it was rotated, let's just say like maybe 70 degrees. So if you have a line that's 6 units long and it's been rotated 70 degrees, it lands in the same exact spot as this point. So instead of using x and y, we use a length and an angle to describe where the point is located. Okay. So let's go ahead and illustrate that again here on your notes. So for rectangular coordinates, like over here, that's what we're used to. For rectangular coordinates, we're used to finding how far over it goes, so that's over 4, and how far up or down it goes. In this case, it's up 3. And from that, we can create a point which we label as 4, 3. Now, with polar coordinates, though, instead of going over and up, we just think how far is it away from the origin. So let's say that's 5 spaces away from the origin. And we also can talk about how far that imaginary line there is rotated from the positive x-axis. So let's say that's about 37 degrees. Either way, you're getting the same point. You're just describing how to get there in different ways. And here's how we're going to write our point there. The 5 represents how far away from the origin that blue dot is, and the 37 represents how many degrees it's rotated away from the positive x-axis. Okay? Now, if we superimpose them, you get the same spot, right? They both land on the same dot, but something really interesting comes up whenever we put these together. Do you guys notice something interesting here? Oh my goodness, it's a right triangle. Okay, so that's why, let's go back to our objective really quick here for the day. I should talk to you about what our objective was. Told you we were going to learn a new way to plot coordinates called polar coordinates, but we're going to learn how to use trig ratios to change it from a rectangular coordinate into a polar coordinate. So we're going to be changing it from xy to r theta. Okay, and we do that using trig ratios because, as you can see, when you put them together, you kind of end up with a right triangle, so you can go from one to the other or vice versa. So here's how we're going to do it. These are our steps for the day. To transform some rectangular, that means regular for us, rectangular coordinates into polar coordinates, the first thing we're going to do is going to plot the point that they give us. The next thing we're going to do is we're going to create a right triangle. The way that we're going to do that is we're going to take the point that they give us and we're going to connect it to the origin. And then we're also going to draw a vertical line to the x-axis. Now that's kind of hard to visualize, so I'll show you what I mean when we do an example. But basically, after you plot your point, you're going to use that point to create a right triangle on the graph. From there, we're gonna have to do Pythagorean's theorem to find a missing side, which is in this case going to be the hypotenuse, which I'll label as R. And then finally, we're going to use SOHCAHTOA to find the missing angle that we need. So, because we need a length from the origin, which is going to be the hypotenuse, and we need a missing angle, which is the angle, of course, for the polar coordinates. So, let's do an example and see how this works out. So, example 1, rewrite the rectangular coordinate given in polar form. So 6, 3. Step 1 is to plot the point. So let's do that first. I'm going to go over 6 and up 3. And then I'm going to put a dot. All right. Now step 2 says we want to create a right triangle out of this. How do we do that? Well, you're going to connect your dot to the origin with a diagonal line, just like so. After that, you're going to draw a vertical line that goes from your dot to the x-axis, just like so. And now, as you guys can see, we have a right triangle. Now, we already know that the base of this right triangle is 6 and the height is 3. Okay? Let's go ahead and move on to step 3 now. Step 3 is to do Pythagorean's theorem to find out what the hypotenuse is, which is what we're going to call the R value. Okay? So, a squared plus b squared equals c squared, which I'll call it R in this case. So we have 36 plus 9 equals R squared. 45 equals R squared. And then we're going to take the square root of 45. And we need to simplify this square root. Now, I'm not going to show my steps for that. We've practiced that a little bit already in this unit. You should be getting 3 square root of 5, though, if you simplify it correctly. So this length here is 3 square root of 5. Okay, that's step 3. So step 1, plot your point. Step 2, draw a right triangle. Step 3, use Pythagorean's theorem to find the missing side. Step 4 is we want to find this missing angle that we have here. I want to find this angle right here, the central angle, the angle that is at the center of our picture here at the origin. All right? How do we do that? Well, what we learned last class will be helpful here. We have two sides that we're started off with, right? We have this side over here, which is an opposite side. We have this side down here, which is the adjacent side. And I want to find theta. So, which equation would I use, sine, cosine, or tangent, if I'm doing opposite and adjacent? Hopefully you guys know that would be tangent. So tangent of theta is opposite over adjacent. And then from there, we're just going to go ahead and solve that equation. How do we solve this? We do arctangent on the other side. So let's go ahead and punch that in our calculator and see what we get. Now, just to make today's work a little bit less confusing, I'm just going to round it to the nearest degree. It's about 26.565, but I'm just going to round it up to 27 degrees. So that's what this angle down here would be. So I can erase that now and put 27 degrees. So let's review our steps yet again. Step 1, plot your point. Step 2, draw a right triangle. Step 3, find the hypotenuse using Pythagorean's theorem. Step 4, use trig ratios to find the central angle. I call it the central angle because it's at the center or the origin of the x and y axis. Okay, so we're almost done. I have my rectangular coordinates here. So what are the polar coordinates? The polar coordinates are the length of the hypotenuse first. That's how far the dot is away from the origin, followed by the degrees that is rotated from the x-axis, which we just found here is 27 degrees. Okay, so these are my polar coordinates. So we're going to do a guided practice because this is going to require a little bit of help probably. So go ahead and pause the video here and do step 1. And when you unpause the video, you'll see the first step completed. Step 1 is to plot the point. That's it. So hopefully you guys were able to plot 2, 8. Go ahead and pause the video here and complete step 2. When you unpause it, you will see step 2 completed. Step 2 is to draw a right triangle by connecting your dot to the origin and also drawing a line vertically to the x-axis. All right, go ahead and pause the video here and try out step 3. When you unpause it, you will see that all worked out. Step 3 is to do Pythagorean's theorem to find the missing side of your triangle, the hypotenuse, which is 2 radical 7. I'll go ahead and record that here on my triangle now. 2 square root of 7. Okay. All right, now we get to do step 4. So go ahead and pause the video here and give step 4 a try. When you unpause it, you'll see that all worked out. All right, so that would be 76 degrees. Step 4 is to find the missing angle by using trig ratios. So we want to find this angle here, the central angle. The opposite side is 8. The adjacent is 2. We could use the hypotenuse, but I would say just stick with the sides that they give you. That way, it'll always be the O and the A, and so we're always going to use tangent on these types of problems for today. So we just do arc tangent of 8 over 2, and we've got our missing central angle, which is 76 degrees. All right, so we're still not actually done, though, because we haven't written our answer out. We've done all the work, we just haven't written our answer. So what are the polar coordinates here? Go ahead and pause the video and see if you guys can actually write out what the polar coordinates are. When you unpause it, I'll show you. The polar coordinates are a combination of how far away from the origin the dot is, so 2 square root of 7, followed by the angle of rotation from the x-axis to wherever that hypotenuse is. And that's the central angle we found, which is 76 degrees. So those are the polar coordinates for that particular point. All right, so we've done an example, we've done a guided practice. Now let's do a student practice where you do a problem completely from beginning to end all on your own. So pause the video here, do all 4 steps, and see if you can get the right answer. When you unpause it, you will see it all worked out. Now I finished this problem pretty quickly, and you guys probably didn't catch it, but if you did, give yourself a pat on the back. You actually didn't need to use trig ratios at all. This is a special right triangle. It's a 45, 45, 90 right triangle. So I plotted my point 4, 4. I connected my line. And I noticed that, oh my goodness, I've got a right triangle where these two sides are the same. And when that happens, that means this is a 45, 45, 90 right triangle, which means the hypotenuse is 4 radical 2. So right off the bat, since these two sides matched, I knew this had to be a 45-degree angle, and I knew that this is the same thing as the legs, just multiplied by radical 2. Now maybe you went ahead and did it using arc trig ratios. It really doesn't matter. You still would have gotten the same answer if you did it the longer way like I showed you in the last 2 examples. It just so happens that this was a special right triangle, so it was a little bit faster. So keep an eye out for that. If you ever get a 30, 60, 90 or a 45, 45, 90, you could save yourself a little bit of time. All right, let's go ahead and move on to our next section for the day, which is to work on some similar problems, but where the coordinates are in other quadrants. Now, let me explain what I mean by that. Every problem that we've done today so far, in case you haven't noticed, has always been in this first quadrant here. I haven't left this quadrant. The reason for that is because of this. A little bit of something complicated happens with figuring out the angle you want whenever it's in another quadrant. So it's not that much bigger of a deal, but it's worth doing separately. So let's see what it looks like. Here we go. Write the rectangular coordinates in polar form. All right, so step 1 is, of course, to plot our point. So we're going to go left 5. And up 3. There's that. Step 2 is to turn that into a right triangle by connecting that dot to the origin. So, boom. And also dropping a line vertically from the dot to the x-axis. Boom. All right. Now, we need to finish labeling these sides. Actually, this is 5 and this is 3. So we're ready for step 3, which is to use Pythagorean's theorem to find the missing side. So far nothing different is happening, right? The last step is where things are going to get a little bit different. Okay, so we've got our R value there, or our hypotenuse. It's square root of 34. And now we want to find the missing central angle, which is right here. So I'll put theta there. And even this step won't seem too different, but there's something we have to do at the end that's a little bit different than usual. So I'll get to that. But for now, let's just stick with what we know. It's going to be tangent, right? Because it's opposite over adjacent. And then we're going to go ahead and arctan on both sides to solve for theta. All right, let me punch that in my calculator real quick here. Arctangent of 3/5. And I get 30.9, so I'm just going to round that to 31 degrees. Okay, so this angle right here is 31 degrees. Now, I'm not quite ready yet, though, to write my final answer, and here's why. This angle is not the angle that I want. What do I mean by that? Well, here's the dot that I want, whose coordinates are -5, -3. Here's the distance from the origin I want, but this is not the angle I want. The angle I want is the angle that goes from the positive x-axis over to there. So I actually want to find this angle. I would encourage you guys to pause the video here and see if you guys can figure out, I think I put 31.5 here, I don't know why I did that. It's just 31 degrees. But I would encourage you guys to pause the video here and see if you can find this missing angle right here, because that's the angle we want. The angle that this point is rotated from the x-axis. Not this distance, that's how far it's rotated from the left side. I want to know how far it's rotated from the right side of the x-axis. So pause the video and see if you can figure it out. So how do we do that? Well, we know that all the way from here to here is 180, and we know that this much of it is 31. So what's left over must be the part I'm looking for. So we would do 180 minus 31 to end up with 149. So the angle I want actually is 149 degrees. So this point in polar form will be as follows. The distance from the origin is the square root of 34. And the rotation from the positive x-axis is 149 degrees. So notice all the steps were exactly the same. It's just that at the end you have to remember that the angle, in this case, that's not the angle I actually want. I want the angle that starts from over here and works its way to my line. So let's do another one here. This time we'll do a guided practice. So let's go ahead and begin here. So pause the video and do step 1, and when you unpause it, you will see that there's my point. All right, step 2, go ahead and pause the video and do step 2. When you unpause it, you'll see that done. All right, there's step 2, turning our dot into a triangle, so to speak. All right, go ahead and pause the video here and do step 3. All right, so that length is the square root of 73. All right, and let's go ahead and do step 4. Pause the video here, give that a try. And when you're all done, I'll show you the solution. And we find out that that little angle there in the middle is about 21 degrees using our old tangent thing. Now, that's not the angle we want, though. So pause the video here and see if you can find out the angle that we actually want. The angle we actually want starts here at the x-axis and goes around in a counterclockwise direction and lands here. Now, some of you guys might wonder, why don't we go this way, Mr. Bailey? Well, technically you could. You would just have to call that -21 if you did that. But just so you know, we're just going to be sticking with positive angles today. So let's always go this way. But technically, you could have called that negative 21. That would have been fine if you would have imagined it going like that. That way, you're still starting from the x-axis on the right side at least. But let's do this one instead. What is that direction? If you need to pause the video to figure that out, go ahead and pause now. I'm getting 339 degrees there. Why? Well, because this is a full circle almost, just minus 21. So 360 minus 21 is 339. All right, so what is the final answer then? Because I still haven't written this out. Here's the rectangular coordinates. What are the polar coordinates? If you need to pause the video and think about it, go ahead and do that now, because I'm going to put the answer up. But the answer is the distance from the origin is square root of 73, and the rotation in a counterclockwise direction is 339 degrees. All right, so that's our guided practice. Let's go ahead and give you a student practice, see how you do with this one. I'll let you guys do this one all on your own, so you guys have got all 4 steps to handle all by yourself. So go ahead and pause the video. When you unpause it, you'll see it all worked out for you. All right, so here's the first 4 steps here. I don't have the final answer written up there yet, but we'll get there. So let's go ahead and go take a look at it. So step 1 and 2, there's in purple on the far left, plotting the point and graphing a triangle out of it. Step 3 is using Pythagorean's theorem to find the hypotenuse, which I got 2 square root of 10. Step 4 is to use tangent and arctangent to find the missing angle, which would be this angle right here. And I got 18 degrees, but we have to remember that's not the angle we actually want. So now we're ready for the last few steps here. So we need to find the angle that starts from this side and rotates in a counterclockwise direction until we get here. So what would that angle be? Well, that's 180 plus 18. So the answer is 198 degrees. So final answer time, drum roll please. The length from here to here is 2 radical 10, and the rotation is 198 degrees. And so there's our polar coordinates for that point. Right. All right. So we're going to plot some polar coordinates now. So this is not an x and a y anymore. Now this is an r, a distance from the origin, and a rotation of 60 degrees. So how do we do this? Well, let's do an example here. So let's go ahead and draw some lines out here. Now, notice that r is equal to 2. So I'm going to start here at 2, and I'm just going to draw a circle that goes 2 spaces all the way around like this. That way, I know that somewhere my line has to be on this circle because it will always be 2 spaces away from the origin. So step 1 is to take this as like the radius of a circle, which by the way is why we're calling it r today, and draw a circle with that kind of radius around the origin. The next thing that we're going to do is we're going to find where 60 degrees would be at. As you guys know, 60 degrees is going to be like somewhere like right about there. So the dot that I'm plotting would be right about here. That dot is 2 spaces away from the origin, and it's rotated 60 degrees from the positive x-axis. And so that is the answer, that purple dot right there. Okay, so what did I do? I drew a circle, and then I drew a radius that was at 60 degrees away from the x-axis, and where that radius touches the circle is the dot that I wanted to plot. Okay, let's go ahead and do another one here. So probably should try to let you guys do a little bit of a guided practice on this one before we give you student practice. So what will our circle look like on this one? We're going to draw a circle. What will that look like? See if you can sketch it. Since my radius is 4, I'm going to go out 4. up, down, left, and right 4. And it's going to hit 4 all the way around, just like that. So that now my circle, the outside of my circle, all those spaces along that line are 4 units away from the origin. Now I want to draw a radius at 210 degrees. See if you guys can draw a radius at 210 degrees. 210 degrees is going to be approximately starting from here, going to up, there's 180. So 210 would probably be like right about there. And so my radius will be about here. And therefore the point that I want to plot is right here. That point is rotated 210 degrees away from the positive x-axis, and it is also 4 spaces away from the origin. So that's how you plot a point in polar form. All right, let's go ahead and let you guys see if you can find where these points would be at. Go ahead and pause the video and graph these 2 points, and when you unpause it, you'll see the solutions. All right, so for number 1, your dot you plotted should have been down here in the 4th quadrant in the middle, 1 space away from the origin at 315 degrees. On number 2, you should have had a dot plotted over here in the 2nd quadrant, kind of close to the x-axis. That dot is 8 spaces away from the origin, and it is rotated 160 degrees from the positive x-axis. All right, so that's how you plot points in polar form. All right, last bit for the day is we're going to learn how to transform polar coordinates into rectangular coordinates. So, believe it or not, this is actually going to be a little bit easier. I want to show you something here. Sine of theta is equal to what? So I have a right triangle here. And if I think of this as my reference angle, this is opposite, this is adjacent, and this is hypotenuse, right? So what is sine? Well, sine is opposite over hypotenuse, right? Now, in this case, though, on this triangle, opposite is y, and hypotenuse is h. Now, what's interesting about this triangle here is that this horizontal distance x tells me the x coordinate, and this vertical distance here, the y, tells me my y coordinate. And this is rectangular form. So I can, let's see how this works out. I want to figure out what y is. So how do I do that? Well, I'm going to take my little equation here. I'm going to get y by itself. I'm going to multiply both sides by h. So those cancel out, and we end up with that. And so we have the following, and this is the part that's kind of important for you guys to write down. Y is equal to, I guess I shouldn't say h though, I should say r, because we're using r instead of h on this problem. The hypotenuse, I'm calling it r. All right, so y is equal to r times sine theta. So in other words, if you want to find out what your y coordinate is in rectangular form, all you do is you take your radius and you multiply it by sine of the angle that you're working with, and that gives you the y value. How do you find the x value? Well, watch this. Cosine of theta is equal to the adjacent, which is x, over my hypotenuse, which is r. And if I want to get x by itself so I can find my x coordinate, all I need to do is multiply both sides by r and I get my x coordinate. So, although I like showing you guys how I got all this, this is the important part to have for today on this particular slide. How do you transform polar coordinates into rectangular coordinates? Well, polar coordinates, they give you an r, a radius, and they give you a theta. Well, interestingly enough, if you just take r and multiply it by sine theta, that tells you what the y coordinate is. If you take your r value and multiply it by cosine of theta, that tells you what the x coordinate is. So it's actually pretty easy to transform something from polar form into rectangular form. You just use this little formula over here. All right. So let's go ahead and take a look at an example here. So, example 4. Graph the polar coordinate above. So that's just a review question, but we'll go ahead and do it real quick. So I want to graph that. So I'm going to go out 5. I'm going to draw a circle that has a radius of 5. And then I'm going to draw my radius at 310 degrees. Now 310 degrees would probably be like right about here, giving me my central angle there. Like that, about 310 degrees. All right, so the point that I want to find the rectangular coordinates for would be right here. So I need to know what is my x value and what is my y value for that point. I know that this line here is 5 spaces from the origin. I know that this angle is 310 degrees. But I want to know what are these coordinates? How far over and down is it? Well, it's pretty simple. All we do is for x, we just take r and we multiply it by cosine of theta. What's my r value? It's 5. What's my theta value? It's 310. And I'm just going to type that right on into my calculator here, and I'm going to get a pretty nice answer pretty quickly. I get 3.2. So the x-coordinate is 3.2. Let's do the y-coordinate. The y-coordinate's the same thing. The only difference is that we use sine instead. So let's see what we get there. Negative 3.8. And there you have it. So the answer is my x-coordinate is 3.2 and my y-coordinate is negative 3.8. And there it is. So if this is my polar coordinate, we can transform it into rectangular coordinates by doing this. Now, why did I have us graph it? Just so we could see that our answer makes sense. If I went over 3.2 and down 3.8, I'm a little bit off on my picture, but we are in the right area here. It's hard to draw a picture exactly right, but there it is. All right, let's go ahead and take a look at student practice here. So go ahead and pause the video here and try to do numbers 1 and 2 here for student practice 4. When you unpause it, you will see the solution. All right, so there you guys have it. That's the graph up here. And here are the rectangular coordinates for this polar coordinate. So that'll do it for today. Hopefully it was helpful. See you guys in class to practice this stuff. Till then.